All right, in the autonomic nervous system, we have something called dual innervation. We know there's two divisions, sympathetic and parasympathetic. We haven't explained those divisions yet. That's starting on the next slide. But what this means is that all the organs in our body, which they're listing on either side of the spinal cord here and either side of the brain, all the organs in our body are innervated by both sympathetic and parasympathetic division. For example, take the heart. Well, you see in kind of bluish purple here, we have parasympathetic control, but in green, which is showing our sympathetic nervous system, well, the heart is also innervated by the sympathetic nervous system, right? That's dual innervation. So one system's going to speed it up, one's going to slow it down. Which one does what? Well, it depends on which organ that we're talking about. So every organ, there's not two hearts, right? By the way, there's only one heart, but they're just separating the two divisions, sympathetic and parasympathetic. You can see all the organs listed here are the same organs listed here, more or less, meaning that all organs have sympathetic control and parasympathetic control, and they will have opposite effects on that organ. And that's what we mean by dual innervation and dynamic antagonism, meaning opposite effects depending on which division of the ANS is in force. Let's start with the parasympathetic division first. Parasympathetic division could be summarized right here. This is a little catchphrase to remember its function: rest and digest. So in order to think of that, just think of this sentence right here in italics as in a person relaxing and reading after a meal. So you're just sitting there, maybe what you're doing right now, you're reading this PowerPoint, you're listening to it, sitting down likely. So right now your parasympathetic division is in use. Rest and digest, you probably maybe already had breakfast or lunch or whatever time of day it is. You're sitting there, so all your digestive organs are functioning, working to digest your meal, but the rest of you is relaxed. Your heart rate's down, your respiratory rate is down, but your GI tract, your digestive organs, is high. So we can see there's different organs for these different processes. So parasympathetic division will lower any organs having to do with the cardiovascular system or the respiratory system, but they're going to stimulate your digestive system, which you can see here, GI tract. And also your pupils are constricted, your lenses are accommodated for close vision. That's why we say reading right here. So there's your parasympathetic division as far as the text goes. Let's go to the structure of it on the next slide. Now the parasympathetic division is also called the craniosacral division because it uses some cranial nerves and it uses some spinal nerves from the sacral region. We'll see a picture of that in a couple of slides to reinforce that. It's going to have, remember, the ANS has preganglionic fibers and postganglionic fibers. It's a two-neuron chain. In the parasympathetic division, the preganglionic fibers are typically a lot longer than the postganglionic fibers, but there's still two, and we'll see that on the picture as well. So since it's also referred to as the craniosacral division, well, what's the cranial portion? Well, you can see here that the cranial portion uses specific cranial nerves 3, 7, and 9, which you might remember are oculomotor, facial, glossopharyngeal. And well, what's the, and also cranial nerve 10, which is vagus. So these are preganglionic neurons, but remember there's going to be a postganglionic neuron. They're going to synapse at a ganglia to the postganglionic neuron. Well, those ganglia have names in the parasympathetic division. If we're talking about these three cranial nerves, 3, 7, and 9, the ganglia are called terminal ganglia collectively. Cranial nerve 10 uses intramural ganglia. This will be a lot easier to understand when we get to the picture, but let's go through the sacral portion. Here's the cranial portion, but let's go through the sacral portion of the craniosacral division, which is the parasympathetic nervous system. So parasympathetic division, also called the craniosacral division. We saw on the previous slide that the cranial portion is cranial nerves 3, 7, 9, and 10. Well, the sacral part of the parasympathetic division uses these spinal nerves, S2 to S4. Remember, spinal nerves, there's 8 cervical, 12 thoracic, 5 lumbar. But when we get to the sacral division, well, the parasympathetic only uses S2 to S4 out of all of your spinal nerves, just those 3, S2, S3, and S4. And, well, these are preganglionic neurons. They'll synapse at a ganglia, and the ganglia is the intramural ganglia, just like cranial nerve 10. You might recall cranial nerve 10, vagus, is the wanderer. It just leaves the head and neck area. It doesn't act like a cranial nerve. It's like it doesn't want to be a cranial nerve. Well, there it is again. It's leaving the cranial area and using the ganglia just like these spinal nerves are using the intramural ganglia. So that was a lot of information there on these 3 slides on the parasympathetic division, but we're going to recap it all on the image on the next slide. This image here, it's not labeled, but this is the parasympathetic division. How do we know? Well, it's also called the craniosacral division. And which nerves are being used? Well, some cranial nerves, and then if we go all the way down here, some spinal nerves. Well, which cranial nerves? Well, we should know 3, 7, 9, and 10. Which spinal nerves? No cervical, no thoracic, no lumbar, but some sacral spinal nerves, S2, S3, and S4. And that's where we get that term craniosacral division, because those are the only nerves that are used, these 4 cranial nerves and these 3 spinal nerves. Does that mean the parasympathetic division only acts around the head and only acts around the sacrum? Well, no, right? Neurons are long, and they'll go through all parts of the body to innervate all these organs. Next thing we covered was the ganglia. Remember, there's a pre-ganglionic neuron and a post-ganglionic neuron, like you can see here. There's the pre-ganglionic neuron, there's the synapse in yellow at a ganglia, and then there's the post-ganglionic neuron. Well, cranial nerve 3, 7, and 9, not 10, will synapse at these ganglia. They each have a name, but collectively, doesn't say here, but just remember it from the previous slides. These ganglia collectively are called terminal ganglia. But cranial nerve 10, if we follow it, will synapse inside the organ itself. It's not in yellow, but can you see the really short postganglionic neuron? But there's still 2. There's a preganglionic neuron and a postganglionic neuron that's really short. You can see it here, 2 dark purple, preganglionic, light purple, postganglionic. So there's another point, is that the preganglionic neurons are much longer than the postganglionic neurons, which are really short, that you can see in light purple. So light purple is postganglionic, dark purple is preganglionic. So cranial nerve 10, which is vagus, and the sacral spinal nerves 2, 3, and 4 synapse in the walls of the organs themselves. So all these ganglia is where the synapse occurs, all these ganglia are referred to as intramural ganglia, which literally means in the walls. Intra, within, mural means wall. So those are the 2 ganglia that are used in the parasympathetic nervous system. So remember those, terminal ganglia and intramural ganglia. The sympathetic nervous system is going to have 2 different ganglia, but the parasympathetic uses these 2. So once again, the terminal ganglia, and then cranial nerve 10 with the sacral spinal nerves will synapse at intramural ganglia in the walls of the organs. So what is the parasympathetic nervous system going to do to things like the heart and the lungs? Well, rest and digest, which means it's going to slow down heart rate, slow down breathing. But what's the parasympathetic division going to do to all of these digestive organs here? Rest and digest. Well, digest. So it's going to stimulate things like the stomach and the pancreas and the intestines because you're in digestion mode.